Next, we have, for this last session one, we have the last speaker, Rahat from Polygon.
Hey everyone, my name is Rahat. I'm here to talk to you a little bit about the Polygon ZK solutions that we offer from Polygon. So Polygon, many of you, if you've already been dabbling in the Web3 space and the EVM space, may be already familiar with our proof-of-stake blockchain. Since for quite some time now, we've shifted a lot of our focus towards building out solutions for scaling in the ZK realm. We believe that there's not really like a one-size-fits-all solution. So while the proof-of-stake blockchain is great for getting people kind of like on the ground, we need to move further and like be able to support like more applications in the space. Just a quick thing, I'm Rahat, I'm a developer relations engineer at Polygon. Previously been a firmware engineer, Solidity engineer, indie hacker, built a bunch of failed startups. But yeah, we'll go into that. So Polygon scaling solutions, we're going to be focusing mainly today on the ZK solutions that we have in the works and the ones that are coming out. These are just a few of the different teams that are working on different ZK solutions in the space. Quick thing about Polygon Nightfall, focusing on low cost private transactions, private payments and applications, especially for enterprises, so more of an enterprise-based solution. Polygon Hermes, this team, the work that they've been doing, this is the work that we're going to be diving into a little bit deeper for today. But quickly, what they've created is an EVM emulation with opcode compatibility. So it works with any smart contract. It works with, you can easily port over dApps that you've already been building in the EVM world. We know Solidity, you can already start using Polygon Hermes' ZK EVM, and we'll talk more about that in a second. Two more solutions we've got in the works. Polygon Zero, which are fast recursive proofs with Ethereum compatibility for high performance and high volume dApps, as well as Polygon Mited, which is fast, safe, efficient private ZK virtual machine with the compatibility, custom virtual machines for the future of development for private transactions. A lot of these things in the works. Some, I can't really give a really deep dive into just yet because the teams are still hard at work getting this through. But like I mentioned, ZK EVM, which was built by the Polygon Hermes team, is what our focus is going to be for today. ZK EVM, again, like I said, allows you to port over any dApps applications you've already built on our proof-of-stake network or on any EVM compatible network, and just works. You can leverage, if you've already been building in the EVM space, you don't need to learn anything new, you don't need to learn any new proprietary language, everything works with Solidity. So there are a few smart contracts that power this solution. First of all, bridge. The bridge asset transfers from L1 to L2 utilizing Merkle trees. So you have, whenever you're trying to figure out how to deposit, so you want to deposit something from L1 to L2, the Merkle tree creates a new leaf that represents that new token. On the L2 side, there is a Merkle tree that validates that the leaf on the original Merkle tree exists, and that's when the withdrawal process takes place. The way the consensus mechanism works on the ZK EVM is called a proof of efficiency. We have two parts to that. There are sequencers that add data on chain, and aggregators that validate that data. We have verifiers, which are smart verifiers that verify the correctness of a ZK proof. This is embedded inside of the proof of efficiency. And when an aggregator verifies a batch, it verifies a start from the ZK proof. So let's dive into a little bit about the ZK node itself. First off, like I mentioned, we have sequencers. So sequencers collect L2 transactions and they get their fees. After collections, they propose batches for verification. So whenever they want to actually make one of these batches, they'll pay some amount of matic to the proof of efficiency smart contract, and that is what actually proposes those batches. This only proposes transactions and doesn't do anything to state. All the sequencer is doing is just batching requests, putting them together, and sending them off. The other side of it, you have the aggregator. So the aggregator, what it does is creates the actual validity proof for a new state on it too. It has specialized hardware that creates these ZK proofs, and we're going to go into some of the software that actually powers this in a second. But the first aggregator that sends a valid proof essentially wins the race. And some matic, so the matic that was sent by the sequencer to actually start the actual transaction, validation of the transaction, that is won by the aggregator that first creates a valid proof. If transactions are processed but are not valid, there will be no effect on the state. So just a quick recap, sequencer taking all of the transactions, matching them together, and then the aggregator is doing the work, starting the process to actually validate these proofs. So how does the actual validation kind of start? We have our ZK prover. So the ZK prover, the executor, is an interpreter that is written in a ZK assembly language. So this defines the actual ZK EVM execution. It includes all of the EVM opcodes, and it can interpret EVM code. So this is like kind of like my favorite part of it. The fact that you can still write, Solidity. You don't have to again learn any new proprietary language. It all kind of just works with some of the existing skills that you may already have building in the space. The whole point here was to make sure that it's easy as possible for developers who are already in the space to start utilizing and using ZK technology. So going a little bit further than that, certain polynomial constraints are actually coded into build language. So build codes are all constraints that must be filled for a transaction to be correct. So the way you can kind of think about this is like, does this transaction have the correct nonce? That's a example of a constraint. Does it have a balance, etc. Just whatever the requirements are for the transaction to actually go through. So this is just a little bit of a flow of how everything works. So at the end, once you've come to the aggregator needing to execute and start the ZK prover, any inputs that it needs to begin the prover are given by the aggregator. The executor then fills all the polynomials, so all the underlying math, everything is computed by the ZK prover. It builds a start, and that start needs to be validated with a start proof. Once the start is completed and proven, it is sent over to the aggregator, who sends it back over to the proof of efficiency contract and verifies the batch. So thank you very much. Just wanted to give you a very high-level overview of how this kind of works. Cool thing is we're the testnet for this specific implementation of ZK EVM should be available in the next month or two. So you'll be able to start trying it out, start building on top of it to permissionless way of just like getting things out there. All of the code for this is open source, available today. You can go on GitHub, look through it, contribute, help us to kind of like make sure that this is done, best as possible. Definitely believe in openness and transparency in this type of technology. So really hope you dive into it today. Thank you.
Thank you. We have time for questions. Any questions for Rahat? No more questions? So we have a question from the community. So one question we have is, you're using Plonky 2 from Polygon 0 for ZK-EVM. What type of improvement or efficiency do you expect the most from this implementation?
Yeah, specifically for this is for Polygon 0, you mentioned?
Polygon 0 uses Plonky 2, so
Yeah.
kind of efficiency.
For Polygon 0, I don't have too much information on. It's still being built in process, so there's not a lot that I can really share at this point. But I've answered ZK-SEL.
And another question is, what other technology is Polygon looking into right now for innovation of ZK-EVM? So do you use lookup table, custom-made recursive proof, or anything?
Yeah, so a lot of, like I mentioned, our consensus model there is like this proven efficiency model. The Polygon Hermes team kind of like went in and built this entire kind of like custom circuit for just like going in, making sure that you can work with the EVM opcodes and all that. So I think that approach fairly different from what other folks have kind of like gone into. The whole point of the ZK-EVM is just to make sure that we're gradually able to get more folks who have already been kind of like in the space, already developing as quickly as possible, kind of like onboarding into ZK technologies as we can. So our first and foremost was just like making that ZK-EVM possible, which is why we kind of like went that route. Some other things, I know that the question asked like other technologies in the ZK realm. Some other things we're working on is like Polygon ID, which is all about like kind of like private identity on chain. So that's another project we have in the works that you can also check out as well.
Okay, thank you.
I just want to ask if this slides or any materials on this are available somewhere online?
So the entire code base is available online on GitHub. It's completely open source.
Right, the code base and the materials like the slides and the write-ups.
I can make them available. Yeah.
Oh, that'd be great, thanks.
Any more questions?
Hello. As a developer trying to choose blockchain network for my company's staff, I feel like Polygon's approach for the rollup has been build out 40 different solutions for rollup and throw it out there and see what sticks. But like, as a developer, it prevents me from actually choosing the solution provided from Polygon because, well, there might be a new product, better product, released tomorrow or later next week, right? Will there be like the rollup solution for Polygon, or are there going to be just like a bunch of products with different features and different objectives?
So I would say for that, I don't think there is ever going to be a rollup for every solution. Our approach has been really to make solutions for different issues, different problems. Like one of our solutions are based on for payments, making payments private, etc. The ZK-EVM is geared towards making sure we get ZK technology out to folks who, dev teams who are more used to working in the EVM world, working in Solidity, and wanting to leverage ZK technology in that sense. So each of the solutions that we make really depend on the team that's using it, and to kind of like look at like what your use case and needs are. So ZK-EVM would be for dev shops who more familiar with Solidity, want to kind of like stay in that realm and want to leverage ZK technology. Some of our other solutions that are coming out, again, some of them are more privacy based, some of them are based on, so like for example, Polygon 0 is more for like really kind of like applications that need a lot more computing power. That would be something that you would eventually go to on there. So it depends on your project, depends on your needs. We don't believe that there is a one-size-fits-all solution, so we're trying to provide different solutions for different use cases.
Thank you.
Okay, thank you, Rahat. Please give a applause for Rahat and Polygon.